In this video, I'm going to start by I'm going to introduce this idea of proving identities or trigonometric identities, which you've looked at in grade 11. What we're going to do now is look at a little more complicated identities using more identities to prove the identities you're going to be trying to prove. So what a trig identity is a statement involving trig components of equality where you're trying to prove that it's equal. So in this I have cosine x plus y, cosine x minus y equals cosine squared x plus cosine squared y minus 1. So what I want to do is prove that these two things are equal, that this equal sign is true. What you can't do is assume that it's true. So you can't treat this as an equation and start manipulating it as you would a normal equation where you if you could, you see a minus 1, sometimes people say, oh, can I add 1 to both sides? Well, no, because you don't know it's an equation. You need to prove that it's an equation. So in order to prove that it's an equation, you must show that this side, which we'll call the left side, is equal to this side, which we'll call the right side. So what you can do is manipulate one side to try to get to the other side, to try to show that it's equal to the same thing. Hardest part, maybe not the hardest part, but a key part is deciding which side you're going to manipulate, because it will often be easier to start with one side versus another. In this particular identity, you have a compound angle on the left side, x plus y, and then x minus y. And then on the right side, you have just what we call single angles, where it's x and y. So as a general rule, it's easier to go from the more complicated thing to the less complicated thing. And a compound angle we would think of as being more complicated. So I will start by manipulating the left side. So cosine x plus y, cosine x minus y. So the way you can manipulate the left side, or any side of a trig identity, is by simplifying using other trig identities, or you can use basic algebra, things like expanding, multiplying, if possible. In this case, I have two fairly obvious or straightforward trig identities I can use, right? Cosine x plus y, I have an identity for that. I know that cosine x plus y is equal to cosine of x, cosine of y, minus sine of x, sine of y, right? That's one of the identities that we learned in the previous section, right? So cos x plus y is equal to this, and then cos x minus y is almost the same thing, except the sign is different. So that's equal to cosine x, cosine y, and then it's plus sine x, sine y. So what's good here is I've got everything down to a single angle like it was on the right side. Now it's still much more complicated on the right side, so I'm going to have to do more. And what you would do here, I've got two brackets multiplied together, so I could just expand. I can multiply the two sides. So cosine x cosine y times cosine x cosine y. So we get cosine squared x, cosine squared y, and you're expanding this just like you would expand normal binomials. So then it'll be cosine x cosine y times sine x sine y. So we'll have plus cosine x cosine y sine x sine y, and then you'll have to multiply this times this bracket. So there you'll have, it'll be sine x sine y cos x cos y. I'm going to write the cosines first, just for simplicity. And then the last two terms would be minus sine squared x sine squared y. So notice these middle terms, cosine x cosine y sine x sine y, minus cosine x cosine y sine x sine y, those cancel out or subtract. So we're left with cosine squared x cosine squared y minus sine squared x sine squared y. So now there's a few different things you could do, but sometimes it helps to keep an eye on what you're trying to get. So I want to get the right side. I want to simplify this to become this, the right side here. Notice that here I only have cosines, but in this I have sines and cosines. So it would be nice if I could change those sines to cosines, and we can do that using our Pythagorean identity. So just to remind you what the Pythagorean identity is, the Pythagorean identity is cosine squared x plus sine squared x equals 1, or if you rearrange you get sine squared x equals 1 minus cosine squared x. So I'm going to make that substitution here. So this would be minus, and then I'm substituting for sine squared. We said that's equal to 1 minus cosine squared x, and then sine squared y would be 1 minus cosine squared y. And now I'll expand here. Cosine squared x, cosine squared y, minus, so I'm going to have 1 minus cosine squared y minus cosine squared x plus cosine squared x cosine squared y. Just expand this negative into this bracket here. You get cosine squared x cosine squared y minus 1 plus cosine squared y plus cosine squared x minus cosine squared x cosine squared y. So notice the last term and the first term will cancel out. I'm just going to write the cosines first here, rearrange a little bit. Cosine squared x plus cosine squared y, and then we have the minus 1. So just writing, sort of reversing the order. And if we look at this, cosine squared x cosine squared y minus 1, that is the right side of the identity that we were given. So we would say that is equal to the right side. So therefore, the left side is equal to the right side. So now that we've simplified it so that the left side is equal to the right side, we know that this identity is true, and we've proved that the identity is indeed true. So that's how you would prove a trigonometric identity.